right, we are jumping into 11.3. 11.3 is going to be lateral area and surface area of pyramids and cones. So we first have to define what a pyramid is. A pyramid is going to be a 3D figure with a polygon base and triangle lateral faces. Now, what you guys need to know, for everything that we do, whatever we have down at the bottom, just assume that that is going to be regular, unless stated otherwise. So if you're looking at this, imagine that it's a square. If you get a pentagon, imagine that it is just a regular pentagon. It's a hexagon, it's a regular hexagon. So we can run with that. Does anybody have any questions? Okay, down here, we got to talk about the anatomy really quickly. That is going to be your base. Up there is called your vertex. All of these sides are going to be your lateral sides. So all the triangles are lateral sides. And here is the thing that messes most people up. If you go from the vertex straight down to the base at a right angle, that is your altitude, also known as vertical height. If you go from, let's say you went to, what is that, Luxor or something like that in Vegas, the pyramid. Okay, so let's say you went up and you slid down the side to get to the side at a right angle. They call that the slant height. Now, why am I bringing this up? If you use the wrong height, you're going to get the problem wrong. I'll tell you right now, and we'll keep talking about it. V equals V. What that means is vertical height is going to be for volume. S equals S. Slant height is going to be for surface area. So make sure you use the V, the vertical height, when you're doing volume. We'll do that later. And S, slant height, when you're doing surface area. And we're going to have to develop the formula. So what I want you guys to do is, here is a figure right here. Let's call this, instead of S and S, let's just call it A, B, C, and D. What I want you to do in your groups is you are going to develop a formula for the lateral area, okay? Obviously, what are all the figures that make up the lateral area? All the triangles. So what I want you to do is list out the area of each one of them, try to use your algebra skills to do some factoring and stuff, and kind of do what we've done in previous lessons with developing the formula, and develop the formula for the lateral area of any pyramid. People at home, think about that. We'll be back in a sec. All right, what is the formula for the area of this triangle right here? It is going to be what? 1/2 AL plus this one, which is 1/2 BL. And then the other one is 1/2 CL. And the next one is 1/2 DL. Okay, what can come out of all of those? 1/2 and L, and what are you left with? A plus B plus C plus D. And A plus B plus C plus D, we can call that perimeter. So what is the formula? 1/2 LP or PL, it does not matter. All right, there you go. That is going to be the formula we are going to use for lateral area. Let's go ahead and write that down. For any figure, all you have to do is do 1/2 the slant height times the perimeter. Now be very, very careful. If you use the vertical height, this is not going to work. Make sure you understand these formulas. Every day we add 2 new formulas or more, and they're going to start getting really confusing if you don't understand how to use the formulas or how to develop it. Okay, for surface area, it's obviously just lateral area, 1/2 LP plus what? How many bases does it have? One. Rather than writing out the formula for this one, which is base times height, another one which is 1/2 apothem times perimeter, and another one that's blah, 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 let's go ahead and just write big B. So that big B could be base times height. That big B could be 1/2 base times height. That could be 1/2 apothem times perimeter. That one could be 1/2 diagonal, 1 diagonal 2. That one could be many different things. No, it's not bad. All right, let's go ahead and do a problem. What? I don't know. I'm thinking about it. So here's the issue. I would love to give you the formulas. The only issue is that the standards say students will know and be able to use the formulas. So knowing, when it says that, it kind of leads me to believe that you're not just gonna write them down and look at them. That's probably what I'm going to do. Probably what I'm going to do is I'm not going to let you put down the formulas. I'll write every single one of them at the top, but I won't tell you which one's which. So you guys will have to identify it. All right, let's go ahead and do this. 1/2 perimeter times slant height. 1/2. You guys are all going to accidentally, not all, but a lot of you, instead of doing perimeter, you're going to do side length, which is what you've done before. And here, if that's 15 and there's 4 sides, then it's going to be a perimeter of 60. And did they give me the slant height, or do I have to calculate it? They gave it to me. And at this point, you can say 1/2 of 60 is 30, and 30 times 10 is 300 inches squared. Now that is your lateral area. Your surface area, on the other hand, is lateral area plus a base. So it's going to be 300 plus a base, which is 15 times 15. I think that's 225. Did I get that right? 15 times 15. Yeah, 15 times 15. 225. Great. 225, and that gives you 525 inches squared. Notice all the work I'm showing. I show the formula, and then I put stuff into it. Okay, does anybody have any questions on that one? We're going to crank through it, and then there's 3 problems at the end where you guys will get practice on your own, but we're going to do them as a group until then. So the first one, lateral area. Lateral area is 1/2 perimeter times slant height. Write the formula every time. Even if you get the answer right, if you don't put the formula, I'm taking off credit. 1/2 perimeter. It looks like the side length is 16, and there's 4 of those sides. Someone needs to tell me what that is. 48 maybe? No? 16 times 4 is 64? Okay, 64. Now, do they give us the slant height? No. So we're going to have to calculate it. Now, you have a right triangle in here. So you're either going to have Pythagorean theorem, special right triangles, or trig. You're going to use one of those. Which one can we use? I don't see a 45, 45, 90 or 30, 60, 90. Pythagorean triple. So if the whole length is 16, then this one is going to be 8. 6, 8, and you don't even have to do the Pythagorean theorem. It's just a triple in this case. That would be 10. And someone's going to have to do that work for me. 1/2 of 10 is 5. 5 times 64 is 320, I believe. Man, I'm good. Man, I am good. Any questions?
If we completely finish the notes, could we move on to the homework?
Not if you're moving ahead of me. You have to wait. Surface area equals lateral area plus a base. Lateral area we already got was 320. A base is a 16 by 16, which I have no idea what that is. 256. That's what 16 times 16 is. And together they get us what? 576 inches squared. Does anybody have any questions? We got one more, and it's the one with the hex. Remember, if you don't know radicals, you can't do 30, 60, 90s. If you can't do 30, 60, 90s, you're not going to be able to do hexagons. If you can't do hexagons, you can't do those hexagons inside of a 3-dimensional figure. So you are going to have to figure out how deep do you have to go before you can find the place where you're messing up. Let's go ahead and do this. 1/2 perimeter times slant height. 1/2 24, and they gave us the slant height, which is 8. Pop that in your calculator. 4 times 24 is, that feels wrong.
12 times 8.
Yeah, what's 12 times 8? 96? Great. 96 inches squared is our lateral area. Surface area is going to be lateral area plus the base. Lateral area is 96. The base is 1/2. Apothem, you guys just need to be good at this by now. That is going to be what? 4 is 2, 2 is 2 rad 3, and then perimeter, which is 24. Those cancel, and you end up having 96 plus 24 rad 3. Questions on that?
I'm very concerned.
All right, let's look at the next one. It's kind of hard to come up with a definition of a cone. A cone is going to be, I'm going to write it as a pyramid-like figure with what? What's different? A circle base. Okay, I'm just going to flat out give you the formula, and you guys are going to have to show me how this formula is the same as the formula we just learned. Lateral area is going to be pi RL, and surface area is going to be pi RL plus pi R squared. I'm going to pause the video, and you guys are going to have to talk to your neighbors and be like, wait a second, that's not the same formula that we had before. This formula up here is actually 1/2 LP or PL. That is not the same thing as pi RL. I want you guys as a group to try to figure out why they are the same exact formula. Giddy up. So once again, we have enough formulas in this chapter to use up a lot of your brain space. If you're not seeing the connections between some, then you're wasting brain space, basically. It seems like this is a new formula, but it's not. The formula we learned before was 1/2 PL. That works for pyramids. What do we call perimeter of a circle? Because that's what the base is here. Circumference, which is the formula of? What is formula for circumference? 2 pi r squared? Just 2 pi r. So we have 1/2 2 pi r L. What do we have here? What can we do?
Oh wait, it's the 1/2.
The 1/2 and the 2 cancel, and you end up with pi RL. So this is not a new formula. You should not pay extra money for it. It's the same formula. How about this? It used to be lateral area plus base. Well, what did they do now that they know the base is a circle? They just wrote the formula for a circle, pi r squared, and they pretended like it was something new. It is nothing new. Really, the only formula you guys need to memorize for today's lesson is 1/2 PL or 1/2 PL plus B. I would go over and just memorize that and then change it when you're doing a cone.
Which is really lateral.
Correct. All right, let's go ahead and do this. So this one right here is going to be the first one. You can start out with 1/2 PL if you would like, but that's just going to be 1/2 2 pi r L. You might want to just go over and memorize pi r L. So pi r L, pi, do we know our radius? 10, what's our L? Did they give it to us, or do we have to calculate it? We have it, it's 15. And that gives you 150 pi in centimeters squared. Surface area is just going to be the lateral area plus 1 base. Lateral area is 150 pi, and base is pi r squared. What's up? Call me out on it, and you get an extra credit point if you find a mistake. Okay, that's not pointable. Let's just call it both centimeters. That was just me going over and messing up when I made the problem. 150 pi plus 100 pi gives us what? 250 pi. Leave it like that. Let the person who's looking at it decide where they want to round, if they want to round. Let's take a look. It's pi RL. Do we know pi? Yeah, pi is pi. Do we know our R? We do not. Do we know our L? No, we don't. I'm going to go ahead and draw it first. They tell us that the circumference, the whole entire circumference, is going to be 10 pi. We need to know, to be able to do this problem, we need to know what the R is, and we need to know what the L is. They tell us that the vertical height, the altitude here, is 5. Can you guys figure out any way that we can figure out the radius? Yes.
So 10 pi into squared is really just 2 pi.
2 pi r is circumference, and they told us that the circumference is 10 pi. Correct.
R is really just 5.
When we divide by 2 pi and we divide by 2 pi, you end up getting an R of 5. So we can already go in here and put an R of 5. We just don't know our L yet.
And then the right angle is, well, makes a 45. The altitude makes a 45.
Ah. So since it's a 90 degree and these sides are congruent, then that must be a 45, 45, 90. So this side must be what? 5, 5. Yay, 5 rad 2. Or you could do the Pythagorean theorem. It does not matter. But I'm all about being lazy and efficient. 5 rad 2. And at this point, I'm going to say that is 25 rad 2 pi inches squared. That is your lateral area. Your surface area is going to be your lateral area plus a pi r squared. So that is 25 rad 2 pi plus 5 times 5 is 25 pi. Now, you could leave it like that if you wanted, centimeters squared. Or you can say, I have this many pi's, I have that many pi's, so I have 25 rad 2 plus 25 pi. Can you combine these things in the parentheses? Are they like terms? They are not. Does anybody have any questions on that? No? I'm going to be nice. Rather than you guys doing these ones and getting practice, I can come by and just test you while you're doing these ones. Okay? Hey, this problem is hard. This problem is hard. It takes several steps. I expect you to do it if you want credit for the homework, because I'm really only giving you very few problems. Make sure that you fully do problem number 3 if you want to go over and get credit for the homework. If you think that you want to do the hardest problem first, I would go over and do number 3 together as a group with your group members in your pod. Anyways, people at home, thank you for watching.